Welcome everyone, I'm Adam. In this problem, we're going to classify and sketch the quadratic surface given by our equation 16x squared minus y squared plus 16z squared is equal to 4. And then when we're done with that, we're going to be using a computer algebra system or a graphing utility to confirm our sketch. So first off, let's try and classify the type of curve that we have. So let's take a look at this. So we have 16x squared minus y squared plus 16z squared is equal to 4. Now if we just pay attention to our square terms, we have x squared term minus y squared plus 16z squared. So we have two positives and then a negative. So what that kind of indicates, if we look at the standard forms of our equations that we know, is we have a hyperboloid specifically of, say, one sheet. Right? And the standard form of that equation looks like x squared divided by some a squared, some constant a squared, minus y squared over some constant b squared plus z squared over some constant c squared, and that's equal to 1. Okay? And we can kind of recognize the graphs of these as sort of an elongated funnel shape, right? And that's why it's in fact called a hyperboloid of one sheet. If you imagine taking a sheet of paper and trying to fold it to make the form in 3 dimensions, you just need one sheet of paper to do it. Versus a hyperboloid of 2 sheets of paper, which are funnels kind of shooting out from each other. Sorry, hyperboloid of 2 sheets, which are funnels shooting out from each other. You need 2 sheets of paper to do that. So here we have this. So we've classified it. Now we want to try and sketch it. So our first step is we're going to take the equation that we're given and try and rewrite it so it's in this more standard form here. So let's take our equation. We have 16x squared minus y squared plus 16z squared is equal to 4. So for starters, we see we have a 1 on the right-hand side, so we can get that if we divide all the way through by 4. Okay. So on our right-hand side, 4 over 4 will give us 1. 16 over 4 cancel, giving us 4z squared. The 4 will stay on the bottom here, and 16 over 4 will give us 4x squared. Now, want to rewrite this as x squared, y squared, and z squared divided by some number. So we can take this 4x squared and write that as x squared, say, divided by, if we take quantity 1/2 squared, would be equal to 4 times x squared. And then minus y squared over 4 is 2 squared, and plus, we have 4z squared. We can do the same thing. We have z squared divided by quantity 1/2 squared, and that's equal to 1. So there we have our hyperboloid of one sheet in its standard form. Now how can we sketch the curve of this, or try and sketch this? Well, what we're going to look at is our traces. So we're going to take a look at the traces, where what we're going to do is systematically drop out one of the variables and look at the curve that we would get in the remaining plane of the remaining variables. So for example, to start with, let's look at our, say, xz trace. Where with our xz trace, what we're going to do is we're going to let, say, y be equal to 0. And so in this equation, if y is equal to 0, that's going to drop out this term entirely, and we'll be left with, say, x squared over the quantity 1/2 squared plus z squared over our quantity 1/2 squared, and that's equal to 1. Okay? So since these numbers are the same, or we could multiply through by 1/2 squared, what we see we actually get here is a circle, namely of radius 1/2. So that's the first thing that we're going to sketch to try and develop this. So coming over here, so in our xz plane, so in x and z, we're going to sketch a circle of radius 1/2. So our tick marks here are counting by 1. So we want a circle of radius, say 1/2. There we go, getting us something like that. So that's our xz trace. Now what we're going to do is build up on this by finding our, say, yz trace. Or actually, let's do the xy trace first. So the xy trace, and similarly, we're going to take z equal to 0. So that's going to give us, say, x squared minus y squared, or sorry, x squared over quantity 1/2 squared minus y squared over 2 squared is equal to 1. Now we can recognize this as the graph of a hyperbola. Okay? So we have a hyperbola in our xy plane. So looking down from above on our xy plane, we're going to have two hyperbolas. Now the transverse axis is going to be the x-axis because we see the negative on the y, and our a number, the number being squared underneath x, is 1/2. So we can see that our vertex is actually going to be at 1/2, or coming through and touching our circle. So we're just going to sketch these. So we want two hyperbolas coming along on our xy plane where the vertices are going to touch the outsides of our circle. Okay. So there's our xy trace. And then lastly, we're going to look at our, what did we say, yz trace. Where, of course, for that, we're going to let x equal 0, okay? And that's going to leave us with minus y squared over 2 squared plus z squared over 1/2 squared, or we'll rewrite that. We'll put this as z squared over 1/2 squared minus y squared over 2 squared, and that's equal to 1. Now looking at this in our xy plane, right, so kind of looking at it from the side, in our xy plane, again, we have a hyperbola, essentially the same thing we did in our looking at our zy plane, we're going to have an hyperbola, the same thing we did in our xy plane. Where we see our a number here is going to be 1/2, so our hyperbolas, with the transverse axis being the z-axis, are going to come through with vertices touching at 1/2, or the top and bottom of our circle here. So coming up in our zy plane, we have hyperbolas in top and bottom, okay, connecting there. And so on the outsides, kind of maintaining our circular figure, if we were to look at this on the end, we would see a circle. Kind of completing our funnel shape. Okay, so there we have it. Okay, so there's our surface sketched by our original equation, 16x squared minus y squared plus 16z squared is equal to 4. Now what we want to do is try and confirm this with either a graphing utility or a computer algebra system. Now, how we're going to do that, we're not going to be able to do it here on a regular graphing calculator. What we need is something with a 3D graphing capability, which won't be too bad. First, what we're going to do is take our original equation and rewrite it so it's compatible to be plugged into something with a 3D graphing capability. So what we're going to have, or what we need, to try and graph this, okay, is we're going to write this as some function f of x and y, or namely, we're going to solve this original equation equal to z. Okay? So in solving this for z, well, let's just kind of take a look at this. So first we have everything equal to 4. So if we want to get z by itself, we'll subtract over our terms 16x squared minus y squared, or subtract 16x squared and add y squared. So we'll have originally 4, then minus 16x squared plus y squared, leaving us with 16z squared. We would divide everything through by 16. leaving us with just z squared. And then lastly, we will take the square root of both sides. With a plus minus out in front. So with your 3D graphing utility, this is what you're going to type in. For your z variable, you're going to type in both the positive and negative of the square root of 4 minus 16x squared plus y squared, all divided by 16. And when we do this, the positive part will give you essentially the top half of this graph. If you can imagine this being cut right through the center, the positive square root part will give you the top half of our funnel shape, or our paraboloid of one sheet, and the negative will give you the bottom half. So putting them both together should give you the entire picture. So there we have it. Thank you very much.